Percentiles? I'm sorry.
No, measures of growth.
Oh, well then call it something else. Call it Sam. Call it Sam. Just call it just pick some name that, smiley face, something that's not, to throw you off. So, what we just did, and I forgot to label it, was we just answered question E1 in the probability distributions homework. And it was a great one. It was a great one. It was the break-even point if you want to finagle the payoff of 3 5s. Fantastic, fantastic question. E2, let's get you started on that one. I think once you see how to start it, you'll be able to go right into how to finish it. Does that make sense? Because, I mean, Danny asked for both E1 and E2, and they're very similar. Both of them are making a game fair, which means you're making the average of a distribution equal to 0. But it's how you're finagling. You can finagle with lots of things. You can change 1 or 2 payouts. You can change the ante. You can change just the lowest payout. You can make people lose less or win more. All of this results in an average of 0. As you saw with the New York Lottery, you can have 10 different games and just change 1. What's interesting about that is, even though, did you catch the bit about the old guy getting drunk at the bar playing the wrong game?
Yeah.
So, if you add up all the different, whatever, play 4, play 5, play 6, play 7 games, New York lost money on the game that these kids played, but they still made money on the other ones that month, right? And they made money on all the other games, all the little scratch-off games and everything else. So they made money on average. They didn't make quite as much that month. And somebody probably got fired or at least reprimanded, like, dumbass, do your math right. So that's the payoff of it. So here's E2. E2 says, let me pull it back up on the screen, to adjust the ante. So here's what we're going to look at now. Bigger. There it is right here. Refer back to the chuckle-up distribution from class. We still have that. Keep the same payouts. Nothing for no 5s, 1, 2, and 10. So LaWanda, when you asked before about you were confused why 2 became 1 and 10 became 9, it's because I'm taking out the ante. I'm taking out the ante. But adjust the ante. So that's why I'm saying keep the payouts at 0, 1, 2, and 10. But you won't have the same profits of -1, 0, 1, and 9 anymore. They have to change because we're going to make the game fair. Is that fair? Mm-hmm. Fair enough, statistically fair, Englishly. Okay, good. Sorry, these are new words. Cool? All right. So I'm going to borrow again some of the distribution. Leave that right there. You can be on the floor, that's fine. Oh. I'm going to borrow some of the distribution from E1, namely this. I can't change that. That's how the dice are falling. So the probabilities are still going to be at 0.57, 5.8, and then 3, 4, 1, 5. Love that. 92% of the time you lose something. And then they give you hope by throwing you some change here. Okay. But what I want to do first, if it's okay with you guys, I'm going to slide over to this side. Let's go back and finagle the old distribution from E1. And let's write this a different way. Let's write this a different way. So -1, 0, 1, and 9. So last week when we were discussing Chuck-a-Luck in class, and I said, okay, so you bet $1 to play. And if you don't roll any 5s, what do you win? And everybody immediately said -1. I said, hell yeah. And then I said, they pay you $1 if you roll a 5, but only one 5. And I said, so how much do you profit? And you all said 0. So what were you really doing in your head? When you were spitting out the numbers -1, 0, 1, and 9, you were doing a little bit of math in your head, yeah?
Payout minus ante.
Payout minus ante, yes? So to get -1, really what you were doing was you were doing 0 minus 1 to get -1, yes? Mm-hmm. Payout minus ante. To get 0, in your head at least, you were doing 1 minus 1 to get 0. Mm-hmm. Right? 2 minus 1 to get 1, and 10 minus 1 to get 9. You were doing, I mean, mentally you were doing something similar to that to get those numbers. Yeah. Ish. Yeah. So here's your ante right here in every single case, and here's your payout in every single case, yes? Mm-hmm. Well, I think we know how to set up our problem now for E2. Now before this was -1, because we knew the payout was 0, and we knew the ante was 1. So 0 minus 1 became -1.
So
we
0, well, it can't be 0.
Go.
Well, X is, if you're going to use this.
That's totally fine. Okay. I'll use question mark instead.
Okay, so
0
minus blah.
Blah. 0 minus something.
Yeah.
call the ante question mark, or call it a variable if you want to. Call it x, call it y. I don't want to use x because we're already using x up here.
Right.
So call it whatever you want. Call it smiley face if that makes you happier. Throw markers if that makes you happier. But you don't know what it is. The question is, what should the ante be? So it's going to be 0 minus that ante. Some of you might be feeling a little bit squirrely right now. Don't worry. We'll come back. We'll deal with the squirrel. We'll kill the squirrel in a minute. What should the next one be?
1.
Minus your ante, yes? Because you have to give that, whatever it is, up. You have to give whatever that is up to play the game. What's the next one going to be?
2 minus question.
Uh-huh. Yes. Let's slide this over here now. Kind of see it okay? That's a lot of question marks. That's a lot of question marks. You don't like it?
I don't like all those question marks.
Don't you worry about it.
Okay.
What do we know about the average of this distribution?
That's 1.
It has to be 0. That's the point, is to make it fair. We want to zero it out. So in other words, we still want to pay him $10 for hitting 5s, or hitting 3 5s. But we have to make sure we charge them just enough so that on average we don't gain money. Now this is a break-even point. They wouldn't actually do this because they can't keep the lights on all night. They can't pull the Colorado River into Vegas and drain it dry. They have to make money to do those things, to pay the bills and whatnot. Yeah? Mm-hmm. So, gut check. The old ante was $1. What's this going to be?
Is it 50 cents?
Roughly 50 cents. It has to be less than $1, yes?
Yeah.
It has to basically counter the money they're making off of you in the previous problem, essentially. Now don't worry about, I didn't actually want an exact number. It was perfect that you did it. Thank you for doing it. My only thing was, it has to be less than $1, yes? It can't be more than $1. If the ante's more than $1, you're going to make even less money on average over here. That's going to become more negative. So it has to be less than $1. But it has to be greater than 0, because if they didn't charge you any money to play, all of your payouts would be either 0 or positive, which means your average would be positive. Does that make sense? So this has to have a value to make this one negative. This still needs to be negative, right? But the rest are then going to be just positive enough so that when it all balances, it becomes 0. So now the question is, how do we figure that out? Well, I'll get you started on this. It becomes this problem again, but it looks a smidge bit different. What you have to do is, I'm going to add one more column, the x times the p of x column again. Just like we did over there. But it's going to look like algebra now a little bit. I apologize. I'm sorry. There's a squirrel again. It looks a little bit algebraic. It's going to be 0 minus question mark times that, 0.5758. And this is going to be 1 minus question mark times 0.3415. And this is going to be 2 minus question mark times 0.758. And this one's going to be 10 minus question mark times 0.0067. And what you'll do is you'll add all that up and set it equal to
1.
Careful. This would sum up to 1. What do we want that to sum up to if we want the average to be 0? 0. And I'm getting an idea. I might make this the quiz for next week. Finish the problem, essentially. Finish the problem and tell me how much on average to the nearest cent they should charge you to play the game to make it statistically fair. Yeah, that way you don't have to rush to do it right now, just to do the algebra. I want you to kind of take time to let it wash over you. I'll make this the quiz for next week. Basically finish E2,
Okay.
if you will. Does that make sense? And I'll set it up kind of as far as we've gotten thus far. I'm going to let you guys kind of finish it. And maybe I'll have it like an extra part of the quiz be like, and I'll finagle it even more. Now make it, I don't know, I think it's something else. Keep the squirrel running. Is that fairish? Do it exactly like you did that. It's just that you're going to have more variables in more places. Madeline, go ahead.
So we've got project, quiz, homework,
Project's Monday.
test.
Project's Monday.
Right, but that's all due next week?
Yeah.
Okay.
You can thank the administration for every 10-week term. Yeah. Sorry.
That's
And the
okay.
quizzes are optional. You get to choose not to do them.
Okay.
So, yeah.
That just seems like
I mean, this is why I didn't put it all on Monday. Then you'd have it all do on one day.
Thank you for not that.
No, you're welcome.
Yeah.
You're welcome. Trust me, sister. I despise 10 weeks. I want 16 so badly. And every couple of years, somebody in Salem has this brilliant idea to push Oregon into 16-week terms, and I rejoice. And then it dies, because it's kind of like making Americans go metric. I mean, honestly. Oregon's too hard-headed. So, sorry. It sucks. And I can keep pushing stuff back to a point,
Yeah.
but the end of the term is looming. And I start pushing things back into the final week of the term, and I'm like, oh my God.
Yeah.
Now I'm doing what everybody else does, which is put a whole bunch of crap in week 10, which kills you guys, whereas right now, you'll only have, I think, a project and a quiz due in that last week. So, I'm trying to look out for you guys, but then I get sandwiched with a holiday. So, apologies. I am sorry
okay,
about it.
that's
No, I am sorry about it. It just sucks. But make the quiz optional. Don't do it if you don't want to do it. That's kind of a nice thing. That's the beauty of it. Of course it was. I know. That's great. Is this fair? Yes?
Yes.
Do we got this? I'll make it a quiz for next one. Write that down so I don't forget to do it. Of course the quiz is optional, yes? You don't have to do them. But I do like having them out there because they do tend to pad your grades. And it sounds like there's still some discussion going on about this, so good. This is good too.
We take 2 classes
Finish
for
E2.
6 weeks. And then you have to work out some of the kids like
Why would you recommend this? Yeah, so like, yeah.
I'll get that posted for you, not 2 hours.
terms.
I want to move on, but not just yet. I want to address an awesome question that Shayna and Serena asked me back there about 10 minutes ago. I'll put you guys on the spot because it was a fantastic question. They asked me, how the hell are we supposed to get these numbers without having an Excel spreadsheet in front of us and only on the F9 button? It's a great question. Especially because your next project is entirely holding on the F9 button and getting numbers randomly generated for. Has anybody started that project yet with the F9 button? I think you'll find it enjoyable in a lot of ways because a large chunk of it is simply holding down an F9 button on a spreadsheet I've already made for you and seeing the results that happen. Much like we've been doing in class, every once in a while I'll pop up an F9 simulator. We'll do it again and again and again. And the answer is we can build these things. I'm going to have you rebuild this distribution more exactly in about a week and a half after we get to talk about the chicken flock, which we'll start today. But don't worry it right now. Right now, anything I ask you to do on an in-class assessment, you will be given. You're going to hint at it on your out-of-class exam. In Excel, when I have you guys create distributions in Excel, I'm going to give you equations that you can pull down and create these numbers. So for example, there is an equation, believe it or not, that generates these numbers. It looks like this. It's going to be P of X equals 3 choose X times, let me see, it's 1/6, right? 1/6 to the X, 5/6 to the 3 minus X. If you take that equation and pull it straight down, you'll get those numbers.
Cool. But you're not going to write us out.
Okay, so I heard one person say cool, I heard a few dry heaves on this side. Because it does. It definitely does. It's a very logical progression, but it requires something called the binomial distribution. Which, no you don't, no you didn't. So what I want to do is I want to get into that today a little bit. But realize on Wednesday of next week, and also the in-class next week, you'll have all these things given to you. And we're going to spend the next 3.5 weeks together figuring out how to describe these things without using the equations. Because I don't want you to get hung up on the equations. I want you to get hung up on the understanding of what the equations are telling you. I want you to look at this and be like, wow, I'm going to lose money on average. That's the kind of stuff I want you to look at. I can teach anybody to put numbers into a formula. I cannot teach people how to understand that this is not a good investment strategy. Please.
So there were 6 die right there? Is that right? How many die were?
3 altogether.
Okay.
And you bet on 5, which means you can either see 0 5s, 1 5, 2 5s, or 3 5s altogether.
Okay, because I know that the first one, I mean, we were doing it out of 216.
It was
which makes-
125 out of 216.
Right, so
And this
where
was
do we...
1 out of 216. So
Right.
Madeline,
I'm trying to figure out where the 216 came from.
oh, 6 outcomes on each die.
Right.
6 times 6 times 6.
Okay.
It's the multiplication for your last project. It's
Got it.
it's called the fundamental accounting principle, but it's multiplication, like your last project. Cool?
Yes.
I thought you were going to go with, okay, I kind of get this, it's 125 out of 216. I kind of get this, it's 1 out of 216. What the hell are these here? And Nick, you may have asked me this last time, I can't remember. Somebody I thought asked me about these 2 in the middle. It could be the other 243 class. They get challenging. The ones in the middle get challenging because you have to keep track of how many ways you can actually get 1 5 and 2 not 5s. Serena, ask me that question.
I just 1 divided by 216 isn't the same.
No, it's not. 1 divided by 216 is the theoretical probability of getting 3 5s. It's less, correct? It's 0.0047 or something like that,
Yeah.
46. This is higher. Remember what I said earlier? I said you guys got too many 3 5s when we did it in class. We only held it down like 3,000 times. If you let it go off to infinity, it'll be 0.0047. That's why On average, you guys saw that there is a $75 payout, yes?
Yes.
I've seen that go as high as $200 in certain classes because this sometimes is underestimated. And if that's small, think about mathematically, if that's small and you divide 0.5 by a very, very small number,
It's gonna be huge.
it's very, very big. And that's why it's helpful, as Serena just pointed out, to be able to calculate these without simulation sometimes. It's nice to be able to get them directly without simulating. That's what we're going to start doing today. So thank you for the question. It was a great one. Make sense? Fair-ish? We're getting there. We're getting there. Fair-ish. Okay, good. Any questions you guys have right now? I want to do a quick exam review for you to make sure that you're at peace with that for next Wednesday. Or should we just do it on Monday?
No, let's do it Wednesday.
No. Let's do the review on Monday. That makes more sense, doesn't it?
Okay, yeah. Okay.
Just in your mind right now, as far as the sections, it's relative position, or SAM, outliers, probability distributions. Okay, it's those three sections. It's the same three sections the out-of-class covers, same three sections that the in-class will cover. Okay, and we'll do a quick exam review, I'll have it made by Monday. I don't have it made yet. I have to go online and get some data sets. I want to find some fun distributions that are already online.
So there are other classes that are going to take it until next week as well?
They're going to take it, I think, tomorrow.
Oh, are they?
I think. Look at my schedule. Man, this holiday just threw me into a tizzy. It's okay. It doesn't bother me all that much, but I'm not sure. I think they take it tomorrow. I'll have to figure it out. I'm going to make it today, regardless. What's that?
You haven't made it yet, they're taking it tomorrow?
Well, I'll make it today.
Okay.
I mean, I don't sleep.
Really?
How many of you guys have gotten emails from me at 4 a.m. and 10 p.m.? Yes. Oh, God, there's a table there. Yes, I don't really sleep anymore. So.
Relative position.
Relative position, outliers, probability distribution. It's the next three homework sets. If you look at the homework sheet, there's 9. Basically, every exam is going to be on 3 of them. So it works out kind of nice that way. Cool?
Yeah.
Now, what's nice about the stuff we're going to be doing today, the remainder of today, and also on Monday, is that it's not going to screw up your exam. Like, it's not going to screw you up for the exam. All it's going to do is it's going to show you where the distributions come from. That's all it's going to do. It's going to show you where the distributions come from. And I think the best way to learn